Today's Tuesday, October 3rd, and we are doing Module 2, Lesson 4. Okay, moving right along. And our learning goal today is to be able to explain to somebody else, or when you go home, you need to be able to explain to mom and dad, or brother or sister, or even your dog or your cat, how you can use mental math strategies to solve multi-digit multiplication problems. Okay? The interesting thing is, when we use mental math, that means we're thinking about the math in our heads, right? Why is it a good idea to learn how to use mental math strategies? Jaden?
Sometimes on tests it says you have to use mental math.
Sometimes it does tell you have to use mental math. Why do you think on tests or in homework it tells you to use mental math? Gia? Yeah. If you can do it in your head, is that faster than writing it all out on paper and doing it on paper? If you can think about the numbers in your head, it helps you solve math problems more efficiently and quickly. The interesting thing about mental math, though, is can I see what you're thinking about in your brain? Can I see your mental math? So what are some things that we can do to make our mental math visible? Marvin, what can we do? Even if we're doing mental math, how can we make it visible to others, to explain to others how we're using mental math?
We write down what we're doing.
Yeah. For example, if we're doing 4 times 3, can you do that in your head?
Yeah.
But if you write 4 times 3 equals 12, does that show me that in your head you were thinking 4 times 3 equals 12? If you just do it in your head, I can't see it. But if you write it down on paper, I can see it. Another example is, do you all know how to do 20 minus 1 in your head? Yeah. What is the equal?
19.
So if you write this out, 20 minus 1 equals 19, it shows me that in your head, you were thinking 20 minus 1 equals 19. But if you don't write anything down, I don't know what you were thinking in your head. If you just write 19, you could have done 1 plus 18, or you could have done 2 plus 17. Does that make sense? Okay, so you have to write down what you're thinking in your head, even when we're doing mental math. Okay? Good. Now, I'm going to have you take 1 minute to copy down everything, not the directions, but everything from under here. There's 6 math sentences plus 1 up here that I want you to copy. Okay, go. So the directions say to circle all of the expressions that are not equivalent. What does equivalent mean? Equal. The same, yeah. So if we're circling each one that's not equivalent to this one in bold, okay, are we circling the ones that are equal or not equal?
Not equal.
Not equal. Okay, very good. So let's take a look. Our expression in bold is 26 times 35. Let's take a look at this first one. 26 35s. Is that the same as this? Yeah, so we don't need to circle it, right? Because this is exactly 26 35s. Do you agree?
Yeah.
Okay, the second one says 36 26s. Is this the same thing as 26 36s? Or 36 26s?
No.
It's actually how many 26s?
35.
How many 26s is it?
35.
35. So is this equivalent?
No.
No, so let's circle it. Okay, very good. Now let's take a look at this next one. We have 26 plus 30 times 26 plus 5. Is that equivalent?
No.
What's 26 times plus 30?
56.
56, okay. What's 26 plus 5?
31.
So this is 56 times 31. Is that equivalent to 26 plus 35?
No way.
No, so what do we need to do? Circle it. Okay. Let's take a look at this next one right here. We have 26 30s, and then we have 26 5s. Or another way to think of this is we have 30 26s, and then we're adding 5 more 26s to it. So how many 26s do we have altogether?
35 and 26.
So is that equivalent?
Yeah.
Do you guys see that? Because at first we had 30 26s, and we're adding 5 more 26s to it. Haley, I want you to pay attention, please. Okay. So Haley, if I have 30 26s, I'm going to add 5 more 26s to it. How many 26s do I have altogether? I had 30 of them, and I'm adding 5 more. So how many do I have altogether? So is that equivalent? Is that the same? Yes. So do we need to circle it?
No.
No. Okay, let's look at this next one down here. I have 35 times of the sum of 20 plus 60. So what's 20 plus 60?
80.
So here I have 35 what's?
80.
80s. Is 35 80s the same thing as 35 26s?
No.
So is that equivalent?
No.
So let's circle it. Okay. Now the last one there, I have 26 times the sum of 30 plus 5. So I have 26 times what?
35.
35. So is that equivalent? So we don't need to circle it. Okay. So do you see did we ever solve 26 times 35? No. Do you see how you can use your understanding of number sentences to figure out which statements are the same and which statements are not the same?
Yeah.
Very good. Now the directions here say to solve using mental math. That means part of it you're going to be thinking in your brain, but you're also going to be writing it out, okay? It also tells you to draw a tape diagram and fill in the blanks to show your thinking. So the math problem we have that I want you to write down is 19 times 50. Okay. Now if we have 19 times 50, that's how many copies of 50? 19. So how many 50s do we have? 19. So you're going to write 19 times 50 equals 19 50s. Do you agree? Okay. Now I can think in my head that 19 is pretty much the same. It's very close to 20, isn't it? Yeah. So if I have 20 50s and then I take away 1 50, would I have 19 50s left?
Yeah.
20 50s. Isn't that a lot easier to work with than 19 50s? Yeah. So if I can think in my head that 20 50s is the same thing. 19 50s is the same as 20 50s minus 1 50. So that's the same thing as 20 times 50 minus 1 times 50. Do you see that? If I draw a tape diagram, and I want everyone to pay attention, if I have 20 50s, I would draw out 20 of these 50s, wouldn't I? But that's a lot to draw. So do you guys see how down in the middle I wrote dot, dot, dot? And then at the end I ended up with 3 50s. You can't do dot, dot, dot to the end. You have to have some 50s at the end. And I can show that this is my first 50, my second 50, my third 50, and dot, dot, dot. It keeps going until here's my 18th 50, 19th 50, and 20th 50. Do you see that? I want you to take a moment and copy this tape diagram so that you have an example of how to abbreviate or dot, dot, dot in the middle of your tape diagrams. If this is my tape diagram, does it represent 1950s? How many 50s do I have?
20.
So does it represent 1950s?
No.
I have to show that I'm thinking of 20 50s, but then I'm going to take away one of the 50s. Once I take away one of the 50s, how many 50s do I have left? 19. So down here, here's what the math sentence would look like. I had 20 50s, so 20 times 50, and I'm going to take away one of those 50s. It's a lot easier to think about 20 times 50 because I can just do 2 times 5, which is 10. And then how many extra factors of 0 do I have?
2.
How many?
2.
So how many zeros do I have to add? 2. So I have 20 times 50, which is 1,000. So 20 50s, the value of that is 1,000, right? But am I trying to find 20 50s?
No.
I'm trying to find 19, so I have to take away 150. What's the value of 150?
50.
50. So if I have 1,000 and I need to take away 50, what do I have left? 950. Do you see how if I think about it in my brain, like 20 50s first, and I can take away one of the 50s, I can do this problem very easily?
Yeah.
So therefore, 19 times 50, or 19 50s, is 950. This time I have 12 49s. Or I can think of it as how many 12s? 49 12s. So I want you to write 12 times 49 is the same as 49 12s. Could I also call this 12 49s? Yeah? Why do you think I decided to choose it to be 49 12s compared instead of 12 49s? Talk to your table group. So in this case, I chose, even though it's 12 times 49, instead of calling it 12 49s, I want to call it 49 12s because 49 12s is pretty close to how many 12s? 50. So I can think in my head that this is the same thing as 50 12s minus how many 12s? 1 12. So using the model we had from before, if I want to draw a tape diagram that shows 50 12s, what I would have to do is on my piece of tape show that each section is worth 50. Oh, no. Each section is worth how much? 12. And I'm going to show that here's my first 12, here's my second 12, here's my third 12, and I'm going to dot, 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 because I really don't want to draw all of them, right? And then here's another 12, here's another 12, and here's another 12. The last one would be my 50th 12, this one would be my 49th 12, and this would be my 48th 12. Do you see that? Okay. Now how many 12s, if I have 50 and I'm going to take away 1, I'll be left with 49 12s. So that's how you would draw a tape diagram to show 49 12s. Do you see that? Very good. So if I have 50 12s, how do I write that as a math sentence? is how many copies of 12?
50.
50. So 50 12s is the same thing as 50 times 12. But I'm not trying to find the value of 50 12s. I'm trying to find the value of how many 12s?
49.
49. So I need to take away how many 12s? 1. Jonathan, how do I write 112 using a math sentence?
1 times 12.
1 times 12. Very good. Now we can do the math in our head. If I have 50 times 12, I can just do 5 times 12, which is? 60. And how many factors of 10 do I have?
1.
I did 5 times 12, which is 60. And how many factors of 10 do I have left?
1.
So how many zeros do I need to add?
1.
So therefore 50 12s has what value?
600.
600. But I need to take away 112. So 1 times 12 is? 12. So I can do 600. Oops, this should be a minus sign. 600 minus 12, which is?
588.
588. So therefore 12 times 49 is? 588. Once again, we're using mental math. We're saying, okay, if I'm trying to find the value of 49 12s, that's basically the value, or I can think in my head, that's 50 12s, take away 112. Do you see how that works? Okay. Here we have 50 times 13. So we can say this is 50 13s, or we can say it's 13 what, Eva? 13 50s. Let's write that down. This time, can we do like 14 minus 1? Would that help us? If we have 13 50s, how can we break that up? Could we say that this is the same thing as 10 50s plus 3 50s? Okay. Last time we were always subtracting 1, right? But this time we're going to do 10 50s and then we're going to add 3 50s. We're breaking up that number into 2 parts that are easier to think about. Do you see that? Okay, how can I write 10 50s in number form? Stella? 10 times 50, very good. How can I write 3 50s in number form? Jaden? 3 times 50, very good. Now we can solve. Hey, look, there's lots of factors of 10, which is so nice. I can just ignore the zeros first, and I can do 1 times 5, which is? 5. And then how many factors of 10 do I have left over, Ananya? 2. So what does that mean? I have to add 2 zeros. So 10 times 50 is what number, Ananya? 500. Does that mean that we're done? 500?
No.
Because that's the value of 10 50s. We still have to add the 3 50s. Again, I can multiply 3 times 5, which is, everyone? 15. And how many factors of 0 do I have? 1. So I have to add 1 0 here. Sorry, factors of 10, not factors of 0. Then I have 500 plus 150, which we can do in our head, and that equals?
650.
Therefore, the value of 13 50s is?
650.
Good. Do you see how that's a lot easier than writing out the standard algorithm and doing all the multiplication?
Yeah.
This is called using mental math strategy.